Our next learning target is using the golden rule of algebra to determine if our equations have a special solution. So the different special solutions are many solutions, and that's when you can substitute any number into an equation and the equation will be true. The second type of special solution is when an equation has zero solutions. There is no number that will make the equation true. So our first example, we have distributive property on both sides. We want to start by simplifying each side of the equation and distributing that value in. On the left-hand side, we have 4 times 3m is 12m, plus 4 times 4 is 16. On the right-hand side, multiplying by 2, we get a total of 12m. 2 times 8 gives us 16. Next, we want to get our variables together. Since both of my variables have the same coefficient, there isn't a smaller coefficient to move, so I'm just going to subtract 12m from both sides. Now, a common mistake that students make on an example like this is they'll subtract the 12m's and get them to cancel on one side of the equal sign, and on the other side of the equal sign, they'll leave an m for some reason. We have exactly the same expression on both sides of the equal sign, and if 12m minus 12m cancels on one side, it will also cancel on the other, leaving us with 16. This is an example of a special solution where there are many different solutions. Any value we substitute in for n will make the equation true because the m's end up canceling each other out, and 16 does equal 16. That is a true statement. So if you get a true statement after the variables cancel, the equation has many solutions. Taking a look at another example, we can simplify both sides of the equal sign again. On the left-hand side, we have like terms. 5x plus 2x gives me a total of 7x. Then bringing down my minus 3 equals, on the right-hand side, like terms, negative 3x plus 10x gives me a total of 7x. So now again, I want to get my variables together. I have the same coefficient on both sides, so I'm simply going to subtract 7x on both sides. Again, we've got 7x minus 7x on both sides of the equal sign. So on both sides of the equal sign, my 7x minus 7x will cancel. Now on the right-hand side, there's nothing left. So in order to represent that nothing, we use the number 0. In this case, negative 3 does not equal 0. So this time we have no solution to our equation, or 0 solutions. So again, if the variable cancels, leaving you with an equation that is not true, there will be no solution to the equation. So now we've seen both types of special solutions. Let's take a look at one with fractions and see if we can figure out whether or not there's a special solution to this one. Now this fraction one is a little bit more complicated. We've got distributive property, so we're going to start on that right-hand side, simplifying our expression. The left-hand side of our equation is simplified, so I'm going to leave it alone. On the right-hand side, I'm going to multiply. Remember, when you multiply an integer with a fraction, you can put the integer over 1 if it helps you organize your work, and you can multiply straight across. So we get 6/16 f minus 6 times negative 3 is 18. Notice there are no fractions on that one, the 6 times the negative 3, so don't let that confuse you. Next, I know that 6/16 can be simplified, so I'm going to simplify that fraction before moving on, because the smaller the numbers in my denominator, the easier it will be to find that common denominator to cancel. 6 and 16 are both divisible by 2, so I get 3/8 f minus 18. Next, what I notice is that both of my f's have the same exact coefficient, so instead of canceling the fractions, I am going to subtract the 3/8 f from both sides because I know that those will cancel out. So on the left-hand side, I'm left with 1/2. And on the right-hand side, after my f's cancel, I'm left with a -18. 1/2 does not equal -18, so I have 0 solutions. Another way to represent 0 solutions is with this symbol, a 0 with a line through it. My last example is another fractions question. And again, on the left-hand side, we've got some distributive property. So I'm going to multiply everything by that -1/2. So I have -1/2 n plus, because a negative times a negative is a positive, and then multiplying my fractions straight across. 1 times 10 gives me 10, and 2 times 3 in the denominator gives me 6. Equals, my right-hand side is simplified, so I have 5/3 minus 1/2 n. Next, I notice that my 10/6 can be simplified. They are both divisible by 2, so I get 5/3 equals 5/3 minus 1/2 n. Again, instead of canceling my fractions, I notice that they have exactly the same coefficient. So I'm going to add my 1/2 n to both sides. This leaves me with 5/3 on the left-hand side equals 5/3 on the right-hand side. Because 5/3 does equal 5/3, this has many solutions. So we didn't see any examples in this video of an equation that have one solution, because all of the equations that we've been solving up until now, we've gotten one solution for. So the way to tell if an equation has one solution is if you solve it, the variable does not cancel, and you get n equals some value. Here are 2 questions for you to try to determine if they have a special solution or if they have only one solution.